right. Okay, we should be live, I hope. Um, Hello everybody, and welcome to another little ad hoc dev stream. On my screen right now is the demo that I am working on for my new XR Tools tutorial system, tutorial series. Falling over my words there. And for anybody who's watched my latest video, I showed how you can make the player in VR pick up these little cubes and throw them around and do fun things with them. So yeah, that was part one. But as you can see, there is some more stuff in here. We've got a few little tools here that you can hang on a tool board. So the next video is going to be about building that and adding some things there to show how snap zones work. So that's the XR Tools implementation to to snap things into place, to put them into specific spots. And we can have some more fun things with that. And then the last part of that is going to be looking at this little gun and magazine setup where you can pick up the gun, load the gun, fire the gun. Eventually the gun goes empty, eject the magazine, etc., etc. And again, using all the basic building blocks in XR Tools so that there is a limited amount of coding needed to sort of glue everything together. I've been wanting to do an Archery implementation for a little while in Godot. So I figured I might just do a quick stream and see if we can get that to work. And I'll just add that into my little tutorial here so that while the video on that subject, because we're going to be using a lot of the same techniques as I used for the gun, the tutorial on that is going to be about setting up the gun. But anybody wanting to look at the demo at that point in time can see also how the bow is implemented. So that is the plan for today. Hi, Shanjak. Hi, Rolf. How you going? Hope you guys are having a good day. All right. So the first thing that we're going to need is a bow and arrow. So I was actually going through Quaternius's things, and it scrolled back up for some reason. So I need to find it again here. I'm wondering if we could use the bow and arrows out of this pack. We're just gonna have to download it and see. It might not. I want to see if he's got anything else on the subject. I don't think so. Maybe that one's even better to use. Let's just because that just has the bows and a few other weapons, so we might just grab that. Do we have a way to download the whole? Yeah, the one that I just want to download the whole folder. Download. There you go. Should have downloaded it before I started the screen, but didn't get there in time. Hey, DJ. Thanks for the nice words. I hope you are enjoying the tutorials and also the streams. While that is downloading, let me also just go into the folder that we need to be in, so that we. I always like to create folders so I know where the assets have come from. Medieval weapons pack. There we go. Has it downloaded yet? I guess so. Go and copy that and paste it over there. All right, so let's have a look at what we have. Oh, that was maybe a bit too quick. So those are the original blends. That's good because then we can see if we need to export them in a different way. I don't want the FBX files actually. So let's go and just delete. I'm not used to Windows 11 yet. So I like to leave the license and preview files in there. let's have a look at whether the OBJ files will do enough for what we want to do. I don't think so, because we won't have the ability to do an animation with that. Let's have a look very quickly whether it might be enough. We can already start with the basics, which is just a new inherited stream. So we go to add-ons, we go to extra tools, we go to objects, and we're starting off with our pickable object again. And we will call that bow. Let's just get a place to save it. So I'm going back into objects, live stream. Let's call it that. There we go, just so that we have it organized and where things are coming from. Nice to hear, Ralph. Just happened to be up. Yeah, it's always a bit of a pain with time zones and people living all over the world, and me sort of just choosing times at random at the moment to stream when I'm able to. So you know, I'm still glad that you can join. So that's good. All right, let's just have a quick look and just create a mesh instance. No, in assets, continuous medieval pack objects. Let's go for the golden bow and see if that one's cool. And of course it's not centered on screen. Why would it be? So there we go. We do have a bow. The problem is that because it's an OBJ file, we can't really animate it. So let's go and have a look at the blend file in Blender. So let's just go and see that golden bow. So is there any rigging done on this? No, there isn't. Excuse me. Let's just have a look if we go in here. The bow looks to be one big cylinder. So no, it isn't. There is a slice here. Very good. That's exactly what we needed to know. Do we use an armature to animate this, or because I am very rusty when it comes to this. I might actually get a different bow. Okay. I might not use this one, because I was looking at another one earlier on. An open game art. I might actually get that one, because that one was rigged properly, but that one didn't have an arrow. So 3D game art. Was it this one? Might have been this one. Yeah, because he also had a nice little tutorial in there. We'll actually grab this file instead. I might still use the arrows from Quaternium's pack, and then maybe at some point I'll actually go through that tutorial of this person and actually get the bow rigged, because that was a very nice bow. Well, I don't like using FBX because it's an open standard, so I kind of avoid using FBX files. This one's going to be called new folder. Okay, and I just downloaded that to here. Okay. Brilliant. What version of Godot? 3.5. Okay, that's for some reason on that. There we go. Well, that's a really simple bow. but that might just do what we want to do. So we're just going to export this as a GLTF file. There we go. And it's just going to be bow GLTF. All right, let's see if that works. So let's get rid of you for now. And instead, we're going to go, what are you called? Bow GLB. You should find bow GLB in there. Why does that not update? There we go. Why do you not like that one? Here, works. Okay, so do it like that then. There we go. Sometimes you just need to trick it. Okay. All right, now for some reason that is oriented wrong, but I don't think we really care for our purposes here. The thing that I need to know right now is if we go to edible children, we go to skeleton, we now have a bone in here. Probably should be this bone here. So we should be able to pose that now. There we go. Perfect. So you can see that the further away we move this bone, the more the bow sort of stretches. So that's really cool. Now, what is not cool is my bow is not colored. Why is my bow not colored? You go. Does it have a material in here? Surface 1, it does. That is material here. So why are you not textured? It hasn't exported the texture. Has it now? No, it hasn't. We know there was a texture in that blend file, so that's our bow texture. So not sure why I didn't save that along. Can we save this texture here? I don't know. Is there a way to do that? All right, so I haven't used Blender enough to really know my way around Blender. So that is here. This brush. Okay, so maybe we just need to see. Where's the look things nowadays? Okay. This is also a non-default view, so I'm a little bit lost. Okay. Did we not have something ticked here to make sure that our yeah, so it's supposed to export the images. And Godot is supposed to import that. So I would really like to just have a file save your image. There we go. Save. Back to memory. All right, so image save as. So actually, I'm going to save a copy cancel. I don't want to change our original blend file. There we go. We now should have a PNG. Perfect. And that should mean that I should be able to go in here and say bow. There we go. Now we have a nicely textured bow. Now I'm still wondering if I should not rotate it. It doesn't really matter. Let's not worry too much about that right now. Okay. Well, Breland, I don't really have time for collabs at the moment, but I'm always interested in knowing what people are working on and what sort of projects you're working on. So Yeah, send some info my way about what you're doing, and I'll see if I can give it some publicity. All right. Let's just start with this very simple bow instead, then, because at least we have our animation in here, and I might spend some time eventually to see if I can get Cortinian's bow to work. Now, again, I don't really care whether it's now lying flat or whether it's standing up straight the way that you're expecting a bow to be, because in the end, it's all going to be dependent on how we are configuring our snap points on how we pick up the bow. So the first thing that we need to do is we need to put a collision shape around the bow. And the collision shape in this case has two purposes. One is for the bow to collide with like the floor and stuff like that when it's lying or when you drop it. And the second is to detect when your hand is near enough so you can pick up the bow. So in this case, I don't really care about a very precise collision shape. It would be nice to maybe have a collision shape that follows the bow, in which case, just for anybody who wants to know that, you simply select the mesh, you go to mesh here, and you can create a tri-mesh static body that will create, and you can see that it's not even orientated right enough, so there is an orientation in our bow already, which is really interesting. However, we get, and I guess that's actually a fine collision shape to use for now. Now, one thing that's also important here, this collision shape is not going to be animated when the bow deforms, but again, at that point in time, we've picked up the bow, we don't really care anymore. So we're actually going to go and use this static body. Now, because we're adding the static body into our armature, which we not where we want it, we're going to get it into trouble later on with that because this structure isn't saved as part of our thing. So you'll see that if I reopen this, it'll actually be lost. However, we do have our collision shape created. So what I can do now is I can say copy, and I can go and place it where I actually want it to be. Interesting enough, that one is correctly oriented. That's really interesting. And now I can delete this guy. Oh, I can't actually because it doesn't see it as part of this, which is my whole problem. So I'll just reopen it. And we'll see that it actually lost that information, but it hasn't lost our collision shape, which is the whole point of this. All right. So with this, we should have a bow that drops itself. Why is this? Oh, that is, yeah, that's just the leftover from when we created that. So we can just, no, we can't delete that. Hold on, what's going on here? Don't save. It has renamed something. That's interesting. That shouldn't be renamed. Oh, we can't even use that. That's even worse. So let's clear that. And I'm guessing that we need to go and clean up that name because that obviously went wrong behind the scenes. So that's an interesting bug. Let's go and say, just open an Atom. Why not? Hardly ever use Atom. For some reason, it's remembered that I installed that God knows how long ago. So yeah, we can see that it has now renamed that collision shape. Now, interestingly enough, all right, let me just take that out. Okay. Let's reopen it. Now our collision shape should be back as that. I wonder why it knew to override the name of that. That's interesting. Anyway, let's retry this. And this time, I'm not going to static body. That's interesting. I didn't know that was typed. So we just do a tri-mesh collision shape sibling here. Let's see if I copy this and I paste it there. Does that one now Okay, so I can't use that one. That's interesting. That's new to me. Oh yeah, of course. So annoying. Let's actually just reopen and not save. Let's try one of the other options. Okay, what about single convex? So that it doesn't really matter that it does that. Let's try one of the other ones. Simplified. Why is that simplified? Well, it does enough for what we need it to do, so I don't really care. Paste. That is not there. Okay. All right, let's see how badly that screws up. Okay, so that's gone now. That's still there. There's no warning. It's happy with this as a collision shape. So, okay. Makes me happy too. Yeah, I don't use Atom at all, Ralph. I just happened to have installed it some time ago, and for some reason, what you call it? Windows 11 suddenly decided to make that as a default, and I have not been bothered to change it yet. I tend to use Sublime, although nowadays mostly I just use Visual Studio Code. So, hey Malcolm, how you going? Nope, you like my beard? Yeah, I am really trying to get a proper beard. I know it's old-fashioned, but oops. Anyway, so the next step is to actually make it possible to pick up the bow. And we're not going to care whether we pick it up with left hand or right hand. So we're simply going to say, let's start with a left hand here. And we make that visible so that we can see the hand. Now we already see a huge problem right now. And that is that my bow is way too big. It's on the wrong scale. And that sucks because I don't really want to scale my collision shapes. What is the right scale for this guy? Transform. I am going to guess. No, that is definitely too small, so it's probably. That actually still looks like a too small bow. That looks like a mini bow right now. That's starting to get to the size of a normal bow. Now, I don't know if I can scale a convex body, whether that will work. It might not. I'm always hesitant to use scaling with the physics engine. The physics engine does tend to misbehave. So at this point in time, I'm wondering if I shouldn't just switch to using just a box shape or some other simple shape. But let's see if we get lucky, because convex polygons are one of the only shapes that are, where we're using an actual tripoly object for collisions, and they should in theory be scalable. I just don't know if it works correctly. Anyway, with that scaled, and obviously this guy now out of the way, we can start positioning our hand so that it's at the place where we actually want to grab the bow with our left hand. Now, in this case, this bow is a very simplistic bow. So there's no notch in there. There's nothing to really help us understand where the hand placement should be. So we're just going to hold it slightly underneath where you would knock your arrow, assuming that the arrow goes past the middle. All right. So we simply start moving our hand around. First of all, orientating it properly. Yeah. I hate it when it does that. So that can probably go back to 0. There we go. So now the hand is in the right order or orientation. And we should be able to move it over. Now in this case, while I think the bow is the right sort of height, let's actually see how big our bow is right now, because I just want to have a bit of a look. Yeah, the bow is definitely too big because the bow is over 2 meters. So maybe it is just a 10% scale that we need on the bow. The other thing that I wonder about is I'm scaling the bow right now. Let's see if our armature still works the way that we want it to work. Yeah, that's still working properly. Good. All right. So we are going to make it 0 0.1, 0 0.1, 0 0.1, and we're going to do the same thing with our collision shape. 1, 0 0.1, 0 0.1. Okay, so yeah, the bow is now slightly more than a meter. That seems to be a pretty decent size for the bow. It just, I don't know, maybe the hand looks bigger than it is. All right. So this hand is right now just a fist. For our purposes here, that is kind of good enough, I guess. It doesn't have to be that precise. It's obviously going to clip through the bow because we haven't really made it into a proper shape. Oh, that is worth trying, Malcolm. That is worth trying. So you think that if I... that was the one that we created. And you can see that it actually applies the transform there. So let's reopen so that it does that. So yeah, it does create it on the scaled mesh, but it scales the collision shape. And again, I guess that for tripoly collision shapes, scaling should in theory be applied properly. So I think it's mostly for primitive shapes, and especially things like spheres and stuff like that, where things will go wrong. Now, one of the things that I could change here, and this is where, yeah, this is where it gets annoying that, oh, this rotation does not work well. Where it gets annoying that I've left the orientation of the bow flat, which is making me think whether that really is a good idea. But obviously we can't really view the positioning of the hand very well. Anyway, we have the ability on our grab points to override the poses. And this is something we still need to improve, that you don't have to scroll all the way down. But it's the last option in the list, XR Tools hand pose settings. And that allows us to override which pose we use for a closed fist. Now, these are stored as animations. And that's just so that we can use blend trees to blend through the different things. So it's a bit of an abuse of what we have, but and then it's always a bit of a question which one would work best. So there's a refresh missing in there, but this might actually work all right enough. There we go. Well, my thumb is still in there. The other option that we have is something that I want to experiment with, and we might actually improve on that once we get everything working. I'm probably not going to use the grip shaft, but we can make our own animation that actually closes our hand properly around the stem of our bow, and especially leaves our finger in a way that we can actually notch our arrow on our finger. So I don't like the grip shaft for this. So let's go and load a different one. It's a shame that we don't have like previews in this, so we can see what each animation is. Maybe the hold animation? That's more like the gun hold. I think I'm using that for the gun one. I actually might just stick with the defaults. This list is too long. And we might later on play around with there is a plugin that allows us to set up the bones for the hand. But for now, we'll just do it like this. Just keep it easy. All right. So we want to do the same thing for the right hand as well, because we don't care whether the player is using the left hand or the right hand to hold the bow. We want them to do either one. And we'll eventually also have to trigger on that, because depending on whether you hold the bow with the left hand, you will want to have the arrow on the right side of the bow. When you hold it with the right hand, we're going to want to have the arrow on the left side of the bow. All right, so here we need to do the same thing. Orient this so that it's correct. All right, and then you like that. There we go. And something like this. And let's see how we are. Oh, we didn't change the height. That's good. I think for what we're doing right now, that's good enough, because we're going to have the arrow go around the center point, because it's going to be notched here and go over that way. So I think for now, that's good enough for what we're doing. Also, I'm probably going to be picking up the bow with my left hand, because I'm a right-handed person. So we're going to work on that first and see if that all does what it needs to do. All right, so with that bow in place, let's go and add our bow into our scene. Now, I kind of like to organize things, so I'm going to put the bow on the left table, and therefore I pair the bow to the table. That's not necessary. That's just the way that I like to do it. So here we go. Here's a bow. And we're just going to go and lay it on the table like that so that we can grab it. All right. Let's go and play. Go back a bit. Let me go and turn the controllers on. Needs to still start up Steam VR, so that's gonna take a minute. All right. Now, it should be darker on screen, the visuals, than it's actually in the headset, because we still have everything displaying in linear colors on screen. Now, also, I'm going to stay sitting down. So I'm going to sit a bit low for this. But for the demo, that is good enough. All right, let's move to where the bow is. Oh, and you can see I can actually push the bow away from my body. But I should be able to now grab the bow. Now you can also see, oh, that's the other problem that we have, because if I want the finger to be like that, I need to push my button, and I don't want to shoot with that. So that's something we need to do. And obviously I can't grab that guy yet. So we might actually use the overrules, but I can grab it with both hands, so that works. All right. And my tracking is a bit off because I'm sitting at a bit of a bad spot for my lighthouses. All right, so that's a couple of things to fix. The other thing, of course, also. All right, so we can see that the that's the margin on the collision shape. It has a huge margin, and it's rolling over that margin. You can see with the other things that we have here, for instance, we have that the magazines nicely show when I'm close enough. So that's something that we want to do with our bow as well. So we've got a couple of things all ready to work on. All right, let's put that guy there. There we go. All righty. All right, let's go and have a look. First thing is we're going to go and have a look at our collision shapes. And here we go, 4 centimeter margin. This is really one of the biggest problems that we have right now. because of the scaling that we're using in VR. And our good friend Bullet is not very happy with the sort of margins that we really want to use. So I'm not even going to make this too small, because this would really need to be like a millimeter. But if you make it too small, it gets all sorts of problems with the physics engine. But it definitely does not need to be 4 centimeters. The reason why it's rolling, by the way, is that it extends a 4 centimeter margin around the shape. And obviously, around the edges that get nicely rounded borders. That's why the bow was like a rolling around. All right, so the first thing is we are going to go and do this after all. Okay. Now, I always forget what the defaults are. So if we go on left hand, grip. So grip is the default closed one. Okay. So we are actually going to go and say we're going to make grip both the closed and open override. And that means that regardless of whether I've got an open hand or a closed hand, which is controlled by the grip sensor on the controller and the trigger sensor. So the grip sensor already makes sure that the 3 fingers, your lower fingers, and your thumb are in the closed position, but you still have your index finger, moving with the trigger. So by making both open pose and closed pose, the closed pose, my hand will always be a fist. So that is a way to make sure that we don't have to hold the trigger as well as the grip, just to make it visually look properly. All right. We need to do the same thing with our right hand. Okay. And in this case, we obviously need to get the right hand animations or we get into trouble. There we go. So that should ensure that whether we're holding it with our left or right hand, we should have a closed fist. All right. So the next thing that we're going to add in here is we're going to use a highlight visible. We also have a highlight ring. This one needs to be used through the scene, so you would need to use the little link button. But for a highlight visible, there's actually not a scene. We just add it as a normal node. And this is a helper node that will make sure that it's visible if a hand is in range of grabbing the object, and it becomes invisible when the hand is not. So all we need to do here is we can add a new mesh instance. And we're going to copy our mesh from our bow. Let's paste it in here. Okay. And obviously we need to apply the same scale on this. But now we're going to assign a material. And I'm actually going to assign a material that I'm already using in my previous part, which is my highlight material. And that creates this nice little highlight effect around the bow. And the way it does that is, if we look at its material, is that this is an unshaded material, so it doesn't react to the lighting. It does not receive shadows. We don't want it to have any effect on shadows. But then the important bit is that our cull mode is front instead of back. Back is our default. That means that we're seeing the back faces of it. And then specifically, we have grow turned on. That means that we grow the object through its normals by a certain amount. So that creates a mesh that is slightly bigger. And actually, we can see that if we do front meshes, it completely encapsulates. You know, the bow is just a shape slightly blown up, a little bit larger. And that gives that effect that we just have an outline around the bow wherever those back faces sort of show through. So yeah, that's a material that I prepared earlier in all the parts that are part of this demo library, or this tutorial demo thing, whatever you want to call it. And it just gives this nice little highlight thing, and it just helps it that we know that we're in reach of grabbing the bow. All right. So if we test that out now, here, again, put my you can see that yellow outline is shown, and at the moment that I got the yellow outline shown, I can actually grab the bow. So now we're going to want to start working on drawing back the bow. So let's work on that bit of logic. It's really funny how the bow wants to lie like that. And that is actually because we can actually deal with that really quickly. That's because our center of gravity is determined by the position of our excuse me. That's determined by the position of our rigid body. So what we could do to combat that, let's go and unfold these, is just select everything, and we'll just move it ever so slightly towards there, so that our bow center is actually more in the middle of our bow. That should make sure that it drops slightly better. All right, so now in order to grab the string and be able to draw it back, we don't really have something, as far as I'm aware, that does that. But there's a very simple trick to make this work. The first thing that I'm going to do is I'm going to add a spatial helper node. And we're going to position this helper node nicely in the middle of our string. And we're going to be using a number of things for that. We're going to be using that to determine where things are, how things need to be stretched, where our arrow is going to be, etc., etc. I'm going to do some fun things with that. Now, what is a good name for that? Let's call that pull pivot. Why not? Just a pivot on which we're pulling. Okay. So the second thing that I want to do here, I want to add a mesh instance to this. And we're just going to call it test. We're going to remove that eventually or make it invisible. But we're just going to give that a sphere. We're obviously going to make that sphere a lot smaller. That's too big. That's still too big. I think that's about what I want, because I just want something that allows us to see where we are with that. So that's just going to be a little helper to visualize where our pivot is, just to see whether our logic is working the way that we expect it to. And the second thing that we're going to do, and this is where it's getting a little bit experimental, but we're going to add another pickable node. And this guy is going to be our pick. There we go. And we're going to turn editable children on here. And we are going to go make that a right. I'm blind. Sphere shape. Last one. um, Now, margins on spheres don't do anything, if I remember correctly. But we're just going to make that there, that. And that's basically just to make sure that we can detect where our pickup point is here. Now, the other thing that we want to do here is we actually want this guy to be a static. And that should automatically go to static as well. Because we don't want this to be falling or anything. We always want that to be placed over there. Before I do anything else, I also want to quickly go in here and say, I want to extend this script to bow. Because we're going to be wanting to react on a number of things. Okay. Cool. All right. Now, the moment we pick this up, this is actually going to become an object that starts, becomes paired to the other hand, and we'll be able to move it around anywhere we want. We obviously don't want our pull pivot to move and our string to go anywhere. We're going to start making our pull pivot follow that around, but only in one direction. I think. And we want to make sure that when we let go of the bow, two things happen. One is then at that point in time, we're obviously going to make it cling back to its original place. We're going to fire whatever arrow is in there with whatever strength our pullback was. And we're going to, at that point, have to move our pull pick back to where it was. So for that, we're actually going to react on our drops. We're not really going to... Well, we actually also want to do pickup, I think. That also reminds me, I actually need to do that with this as well. All right. That's right. So this guy is actually going to be... The other thing is we don't want to pick our bow up by our string. So that's going to be an important thing as well. So what we're going to be doing is we're actually going to disable this by... Now we don't have an enabled. That's interesting. Malcolm, we need an enable property on this thing. Ah. That's interesting. That is really interesting. Because we only want to enable this when we're actually holding our... That's actually a really good one. We probably should indeed do that through the filters. That is probably the easiest way to do this. All right. Okay, about pickup layer. This actually does not need to collide with anything. Absolutely shouldn't. And our mask should be off as well. Okay. Cool. Let's indeed do that. All right. So let's start with our bow. Okay. On bow picked up. Perfect. So the nice thing about this is now also we get our... Oh, what are we sending to that actually? That's a good one. pick up by with controller. Where are we missing that? No. On the do precise grab, okay. And on the, okay. So we do that once we're actually picked up. That's good. But why are we sending self to it? We're telling, oh yeah, because, yeah, of course. So we don't actually really care about that because we're doing an internal reaction here. So the first thing that we're going to be doing here is when our bow gets picked up, enable our pick. All right. So, hey, Chevalier. I am doing well. Thank you for asking. Okay, so, actually make that one ready for pick. I kind of like to have these guys around so that if we ever change where they are, it becomes easier to change the code. So this needs to be the collision layer, and these are flags. So in this case, because we want it to be in collision layer 1, didn't I? Oh, that's right. This one I could have because we want it to be in collision layer 1, that is actually still 1. Not cool. Set 1. Thank you. All right. And when we drop our bow, do a little bit more. Let's go and hide that so that we can use autocomplete a bit better. Picked up. I don't want to free it. I just want to drop it. Let's go with it. In this case, we don't actually care about that because there's no velocity in dropping those things because it's static body. So that makes sure that that is no longer held. And now we can simply say disable our pool. To be consistent in how we write things. We're simply going to make our layer 0, and that should prevent us from being able to grab the string and get some really weird things that happen. All right, cool. Now, you're going to think that I'm wondering about is, should I have... No, it's going to be part of this. So, here we also want to do a picked up. So here's going to be full picked up. Let's just make sure these have underscores so that we don't get warnings. And we also want to go and do the same with the drop. Okay, perfect. And that means that we now also want to have a process function. There we go. And now whenever you define a process function, that means that process is turned on by default, but we're actually going to turn it off. We only want to run our process function when we're holding our little pool pick. Because we're going to do the repositioning inside of process. Now, actually, I'm not. Am I? No, I want to do that nicely on the drop. So, fire our. There we go. So the moment that we drop that, we're going to trigger the firing of an arrow. Now we don't have our arrow yet, stuff like that, so it's coming. Not doing that just yet. Now the other thing that I want to do is obviously have our grabs for this correct as well. Now here it gets interesting because we're actually going to be moving our hand, and we might not hold the hand properly on the string. Now, also for arrows, we would really need a pose like this. I guess we could use our V pose, but have it. But seeing that we don't have that right now, we're just going to do our default pose again. And in that respect, let's hide that. I'm actually probably just going to copy these two so that we have all the same settings there. I'm just going to go and paste those there. Okay, that was not a smart idea. All right, let's get rid of you guys. We're going to add that in. Points. Left. Grab points. Right. So I guess when the copy works, not checking the owner properly. That's interesting. Because those extra hands, they are virtual objects. The fact that we see the hands here, these guys, they're actually not really there. They are temporarily created in editor scripts. They're not actually part of our scene. So as long as you leave the owner of the object blank, those nodes should be destroyed when you close your scene. They're not saved as part of the scene. But obviously, they are being copied, which is not what we're supposed to have. All right, so I think it was 90 minus 90. There we go. That's working properly. And again, we need to go and position them. And we just position them on the string for now. Like that. It's not correct. That's not how you shoot a bow. But for now, that is good enough for what we want to do. So again, the same thing goes. We're going to support our left hand. We're also going to support our right hand. This is also 90 minus 90. Yep, perfect. But our up. No, it's actually, I think that's this one. Yep, it is. Okay. Let's actually copy them so that they're both in the same place. And I'm guessing that this one needs to actually be positive instead of negative. All right, cool. So yeah, we're now holding our bolt. All right. Let's hide you. Okay, now let's have a look at what exactly happens on our let go. Here. Perfect. So let go. So yeah, we are using actually for this one. Yeah, we're using remote transform. So yeah, because the thing is that it's going to reposition it, but it's going to be placing it where we were. And we don't want that. We want to snap it back to our normal location. And that's really easy because our transform is actually 0, 0, 0. Because we're going to put our pull pick back on our pivot. So on our drop, we want to go back to start location. that is now pull pivots. Let's do the same thing. And ready var pull. Okay, that's interesting. We've got that wrong because no, it is pull pick. Yeah, sorry, I am thinking wrong. So pull pick dot transform becomes transform. So we reset it back to a normal identity transform. And that should make sure that our, when we let go, our pull pivot isn't going to be wherever it is, but it's going to be, sorry, our pull pick isn't going to be wherever it is. It's going to be back on our pull pivot. All right. Cool. So the next thing that we need to do is as we stretch, now our pull pick is floating around in space. Yeah, it's floating around in space. So we're going to want to adjust our pull pivots accordingly. And that's something we're going to be doing in our process function. So here we're just going to double check if is picked up. Only then we're going to do our logic. All right. So what we now want to do is is there a good one? I need to save. Okay. Oh, that can also be non-ready for. Pull pivot original transform is we're going to make a copy of the transform where pull pivot is right now in our scene. Because first of all, we need to be able to put it back there to, you know, to spring back our, our bow to starting position. But we also need a reference point to see how far back we pull. All right. So all right. So the first thing that we want to do is we want to look at where our pull pick is right now. Because remember, our pull pick, when we grab the string, our pull pick is going to be following our hand around. So that allows us to know how far back we need to pull. In order to do that, we are going to get our location of our pull pick, but in relationship to our bow. We're going to take the global position of that, and we're going to transfer that into the local position relative to the bow. Right. Cool. All right. So what we want to do for that is pull position is going to be global transform. So that is a transform of our bow because we're in our bow script. And we want to do inverse transformation. And for this, we want to get our pull pick global transform origin. All right, so that should give us the position of our hand in relationship to the bow, so in local space of the bow. Cool. Now, just for fun, just for start to see what's happening, is to verify this is correct, I am going to, this is wrong, but I am going to do it that way right now. Is I'm just going to place our pull pivot. Do I? Yeah, I do want that, I think. On ready for pull pivot. Fish. So. Now, I believe there's a way to actually have these names unique, and then you can use shorthand for that as well, but I really need to look up what that syntax is. Okay, so for now, just to see if this works. That's interesting. Because that's the other problem that we have. Does that matter? Ah, thanks, Malcolm. Not that I'm going to use it here yet, but that is really cool to have in the future, I think. Okay. So, full position. That. Okay, so I want to actually do current full pivot position. Actually, get the whole transform there. No, there's going to be a local position. So here we're going to get transform dot origin, because we're only interested in placement. We're not interested in anything else. All right. So now we can say full pivot dot transform. Remember, we're in our local position of our space right now, of our bow, so we can simply set that to full position. And I want to change this because I don't want it to move up and down and left and right and stuff. I only want to pull it back, but we just want to start here to see if it's doing what we think it needs to be. And then something that we are going to keep is, now that we move our pull pivot, we're also moving our pull pick. And that is being updated with a remote transform. That's going to be interesting, whether the remote transform is going to be a frame behind or not. Well, you know, I'm actually going to assume that the remote transforms are already applied at this point in time. But because we're moving our pull pivot back, we actually need to counter move our pull pick. In this case, we can do that in local space because of what we're doing. So we are going to do current position minus pull. So we're going to subtract the we're just going to counter that movement, and that makes sure that our hand actually doesn't start vibrating or anything like that. All right, let's see if we got a good so far. So at this point in time, the effect should be that our test pull, this is why I have our test here, so that we can see what our pull pivot is doing. That should not, oops, that's not what I want to do. That should not stay on our, call it rope. That should not stay on our string rope thingy. That should actually follow the hand around right now. And it's not what we want. We're doing too much now, but it's going to be our start. All right. So. Let's see how well this works. And of course, I have rolled over my cables on my chair. There we go. All righty. How well is this working now? 1, 2. Oh. My controllers have shut themselves down. That's good. Let's see, are they coming back online? Yes, they are. Other hand, there we go. Oh, we're getting lots of frame drops for some reason. All right. So now when I grab this, ooh, we get a breakpoint. Okay. What is it I'm happy about? Because that should not be transform, that should be transform.origin. Same for this. We're not changing the whole transform, we're changing our origin. There we go. All right. Let's see if we get more lucky now. Yeah, I'm definitely getting some frame rate issues, but I think that's more. All right, so as you can see, our ball is nicely following our hand. And okay, so that's not springing back to its old place. Now, I don't know why I'm suddenly getting these frame rate issues. But something is hogging. Oh, maybe that's because of sort of the blender turned on. Let's go and turn blender off. Don't save, don't worry about it. Okay. Something's definitely pulling performance away from my computer. That's not the game, by the way, because it's running fine. I'm not streaming and I'm running it from scratch. So it's something on my computer that's being naughty. All right. Okay, so our pull pick goes back, fire arrow to be done, and then when we fired, move our pivots back. So this is going to be pull pivot transform origin. Actually, I'm going to change that position. There we go. So we're going to actually do this as position, because we are never going to do anything with the orientation. And also, I've got my little trigger finger again, but I'll do that later. All right. So now we have the ball following our hand around, and we don't want that. We want it to stay on our, basically we want our pivot to just move on that one axis. So that should be, it's actually in our x-axis on this, because again, our bow is rotated for some reason. It's really interesting. Yeah, it looks like on the red axis, so local on the X. Let's see if we're right about that. So what we actually want to do is we only want to adjust the X position for that. Now, the other thing that we want to do is we want to clamp this. Now, when we look at our pivots, you can see that we've moved that 0.1. Okay, that's cool. So we want to clamp this guy between our full pivot original position of X and let's say 0.5. Say that that's the maximum. So when we stretch our bow up to the maximum position, if we go further with our hand, we want that to stop. Cool. This is all stuck to each other. Why? There you go. Alrighty. Let's try this again. Oh, crap. Now you can see that our ball is only sticking on that x-axis. It doesn't go further than that. That's as far as our ball will go. We can pull it back, and that's as far we're going to pull it back. All right. So let's see if we can make our string react to this one. Again, I'm getting the same weirdness with my frame rate for some reason. I don't know why. And after I let go, for some reason, it is no longer doing that. I think that's our, it might actually be our physics engine that's going haywire. I think our physics engine is not happy about something. That is outside of this video, this all. Okay, so on our dropped, we set our process to false. We do that, we do that, okay. Yeah, I don't know. I don't know. Anyway, one problem at a time. Shall we not? So now that we've moved that along the z-axis, we know how far back we've pulled. So actually, no, I don't think we should have bones because we're not actually using our animation in this case. So let's see how far we've moved it. Pulled back is pull pivots dot transform origin dot x, and we're going to take away our pull pivot forward position dot x. So now we know how far we pull back. Now we know from what the original position here was, that's going to go from 0.1 to 0.5. So we have a movement from 0.0 to 0.4. Now what we also remember is when we adjusted our skeleton here, if we're only moving this 0.4, which is our maximum amount of movement, we see that it's moved just a little bit. I'm guessing that that would be our, our scale again, our 10% scale. So my guess would be that will be as far as we've pulled it. Now let's say if that matches, that's not far enough. I think we might need to stretch it even more. But that at least gives us an initial inkling. So that's the guy that we are going to need to change. Righty. So let's go and get our skeleton. All right. So skeleton, that's the guy that we need to adjust. Cool. Now some rest pose transform. Pose transform. All right, that's the other thing, of course. We are, in our scene, it's on the X, but because of this weird twisty thing around, we're actually doing it on our Y in here. So yeah, pose transform dot origin dot Y. So let's make sure that that's a uniform transform. So that can be pulled back times 10. And now we should be able to do pose skeleton set pose. Is it set custom pose or set pose? I don't actually know what the difference is. I'm going to assume that it's bone pose. So that's our rest and that's our pose. Let's go and have a look if there's something in the... What's the difference between, no, let's get set bone pose and set custom pose? Well, of course, there's no help on that. Why would I be helping something like that? All right. So we're changing pose number 1. We're giving it our pose transform. That also means that we obviously want to reset that as well. Okay. There we go. We got you. All right. I was pulling back, but, and then of course, after that, it doesn't work anymore. Oh. It's all right, all right, all right. What are we missing? Now, the first thing that we're going to do is in debug, we're going to set visible collision shape so that we can see whether our pull pick is doing what we think it should be doing. All right. Excuse me. But the other thing is that seemed to be moved by half of what we're moving our pose. This does not make any sense to me. But let's see if that's true. Keep having everything tangled. All right. Yeah. Oops. I grabbed the. I don't know how I managed to do that when I'm this far away from it, but oh, those are our range collisions, I guess. Anyway, whatever. All right. The thing here is that we can see our collision circle there, which now moves away with this. Ah, see, that is exactly on there. So don't ask me why we need to double that thing, but that's a decent drawback of the bow. Okay, that goes back, but after that, we can no longer do that. Now, if I remember correctly, I've run into this before. And Malcolm, if you're still here, you might want to look at this as well, because the problem here, I think, is that we are calling, where are you? We are going let go. Oh no, that's on the bow drop. That's if I drop my bow. Because I remember having problems that if I do that when the thing is held by a snap point, it's actually not removed from the snap point. So the snap point still thinks it's holding it, even though you've let it go. And I'm wondering if we have the same problem with here, which is actually really easy to change by simply doing point drop object on this. And if I'm correct, our function pickup should have a drop object. So trying to find needle in a haystack. Yeah, has a drop object, and I think the same thing is true for the other thing. So I think that's safer than doing a let go. So that's kind of cool. Okay. Yeah, we don't change that one because we're only turning that off and on our bow picked up and bow dropped. So we've got it on 0 at the start, and when we pick it up, we set it to collision layer 1. And that is our problem because, yes, that is the problem. Because on our pickable objects, we are restoring our original collision mask, which is 0. Thank you, Ralph. So we need to make sure that when it's dropped, oops. Oh, why did it not? Layer is 1. Move back to start location and re-enable. Because yeah, we remember what the original collision layer was when we start. So that's another thing, Malcolm, that we might want to think about in our logic, is instead of recording our original mask at startup, is to record our original mask as part of our pickup logic, so that it returns to whatever mask it was when it was being picked up. That might be safer. I don't know. The only thing that I worry about is if we do that. Nah, that should be the collision layer that it should return to. So that would possibly be a good idea. But this is a good way to work around that. Okay, so we now saw that our pivot is nicely following how far back we want to draw our bow, and that when we let go, it plops back into place. Cool. So the next thing that we need to do is load in an arrow. Cool. So this is where it is going to be very important that we have that pull pivot. Because so far, I could have just done that pull pick and just calculated how far we draw back and do our animation. But I wanted that pull pivot there as a node that actually follows there so that we can have that working properly. Now, the simple thing that we could do right now is we could anchor our arrow here as well. The problem that we now have is that we could snap the arrow away when we grab this. So instead of grabbing our grab point, we might end up grabbing our arrow and pulling our arrow off of our bow, which is not something we want. But there's a nice little trick that allows us to circumvent that, but also allows us to immediately do our arrow the correct way. So what we're going to do is on our pull pivot, we are going to do a snap zone. Boom. There we go. So now we have our snap zone over there, but we're now going to move our snap zone. Now for now, I'm just going to put it over there. I might actually move it back further. So this is what we're going to snap our arrow on. Now our snap zone, let's make sure that our snap required is going to be our arrow. We don't have our arrow yet. We're going to make that next. But yeah, we're going to go and put our arrow on there. All right. Cool. But yeah, I might actually move that a little bit further. Anyway, our graph distance is 0.3, so we have quite a bit of distance there. We know that 0.1 is over here, so it's about that range. If our arrow is within that range, it will snap to the bow, or will actually snap to that snap point. But the nice thing as well is that when we pull back this, we're also pulling back our snap point, snap zone, and therefore we are moving arrow. Alrighty. So let's go and rename that to arrow snap zone, and let's go and make our arrow. So because we want to be able to snap our arrows and we want to be able to pick up our arrows, we need to create another inherited scene from our pickable. And we're going to go and call that arrow. And in this case, let's go and save that as well. Arrow, save. So in this case, we're going to be using one of Quaternius's arrows. Here we go. And for that, we need to go and add a mesh instance in first. Boom. Arrow. Put you in there. All right. Now, the nice thing is that our arrow is at the end, which means that our arrow will be unbalanced. We actually want our arrow to be nicely in the middle. So the problem now is actually, let's go and why is that snapping? I don't have snap on. Anyway, where are we now? 2.56. You want to see how long our arrow is? 7. All right. That's a long arrow. It's a really big arrow. Before we do anything more with that, we are going to go in here and mesh instance. We're going to go and put our arrow here. There we can see that our arrow is much too big. You can also see that our arrow is not rotated right. Interesting. Okay. Let's see if we make the arrow half the size, whether that is starting to look okay enough. It's still too big. How about quarter the size? That's starting to look okay. 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 That's decent. Now, at this point in time, our arrow is going to go straight through our bow. That is, of course, not very realistic. But normally that would be a cutout in a bow. It would be slightly off center because I don't know if anybody knows about bow science, but bows actually are flexible and they actually go flip, 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 flip through the air, which is really interesting. So the bow is actually not pointing straight. It actually is slightly slanted when you pull it back. But for our goals right now, we're going to do exactly this. We're not going to do anything different. Now, I'm not going to worry about the rotation of the arrow. All that I did this for right now is just to see if our arrow, well, the correct resizing is. So we're going to make it a fourth of the size. So obviously we need to do the same thing here. No, transform 0.25, 0.25, 0.25, boom. And bring it back. Zoom in. Over there. This is just to see how long our arrow is. So our arrow is, let's say 0.7. Let's move it back 0.35 and say that that is our center point of our arrow. That is good enough for me. All right. So that means that over here, I actually want this to be no, it's going the other way around for some reason. I'm not sure why. Because one of the things that I'm wondering about is, because the snap point is then going to be there, is to actually make that sit like this. So in rest, we snap it back there, we pull it back, and we let it go. I think that'll do fine. Okay. I'm going to hide that one. That was just for helping. Actually, we can get rid of that for now. Okay. Again, we might need to rotate it depending on how it snaps. But we'll see. Yeah, I'm actually pretty sure that needs to be rotated. So we already know that was 19. But yeah, of course this. I think it needs to be the other way around. I'm guessing, seeing how we match that on the other one. All right. Cool. Let's go and give this guy a collision shape. And for that, we're actually going to give it a capsule shape. All right, so our radius needs to be nice and small. This one then also needs to be transformed 90. There we go. And then in this case, this should be 0.34. No, 0.6. There we go. That's going to be, so it's going to be slightly extended, but that's fine. We don't really care too much about that. And then again, our margin is way, way, way too big like this. So here we are going to do a 1 millimeter margin and hope that our physics engine is not going to mind. All right, so that should be our arrow. And the last thing that we need is we do need a grab point. That as this one. So that's a grab point for snap. And we're not going to care about how we're holding it at this point in time, I think. All right. Yeah, I think that's good enough for our arrow at the moment. All right, now the last thing that we need to do is we need to make sure that this is in a group called arrow, because that is going to work together with our snap zone here, where we said we only want things that are in the arrow group. Normally you would handle this with collision layers, but we found out that that was confusing to many people. And the group logic just seemed like a much better way to do things. Plus that you can mix and match. So you could have, for instance, an ammo group to indicate that things are ammos, but then you could say, well, this is a sniper ammo, this is a pistol ammo, this is, arrows, so that you can classify the different arrows so that they can only be used by the correct weapons. But you could store them all inside, let's say, an ammo bag or something like that. So some fun things that you can do by combining groups and making it all filter on groups. Okie doke. So now for the last bit of fun. So the first thing that we want to do, need to reselect that, there we go, is we want to react to when we actually pick up an arrow. Again, we don't really care about what we're picking up. We know that we can only pick up arrows. The crazy thing that I'm going to do here, so I am going to make another on ready for arrow snap zone. That's going to be a XR tools snap zone. Let's go past it. Let's see what's not done. So when we load up our arrow, we are going to go and disable this. And the reason for this is normally when you have a normal snap zone, you leave it in an enabled zone, because once you place something in a snap zone, you can then take it out again. Now, in this case, we don't want to do that. First of all, we don't want to accidentally grab our arrow out of our snap zone. Excuse me. Actually, I need a drink. I'm getting a bit dry in the throat. But second of all, once we fire our arrow, the snap zone's logic would immediately snap the arrow to the bow again. That's not what we want. So we're going to leave the snap zone disabled for a few seconds. Well, not a few seconds, probably half a second. So that once our arrow is fired, we are going to not enable our snap zone until the arrow is nicely far away. Now the other thing is, and this is something that I'm still discussing with Malcolm, I was discussing with Malcolm the other day, which is it's actually a lot of fun with the gun, because it's kind of like a nice game mechanic. But I could actually pick up arrows or load arrows by just moving the bow close to the arrow. I don't actually have to pick up the arrows. So there's something that we want to do to make sure that you can only load an arrow into a bow, or only load a magazine into a gun if you're actually holding it. So that's still something that we're looking at. And that's also why I need to be careful, because if I put a whole bunch of arrows here on the ground, you'll see that one of the arrows will automatically snap to the bow, and we'll load those arrows. So that's not something we want to do. Let's go. Let's actually move our bow in a little bit to the left, so that's there. All right, and let's go and load our first arrow in. Go. There's an arrow. Put up. Okay. You see that's oriented the same as that, which not what we want. In this case, we're going to rotate again by 90 degrees. Focus correctly. Call that arrow 01. Yeah. Move that down a bit. That's the way. duplicates, another arrow, duplicates. That might still be too close to our bow, so we might still get that our bow will snap the first arrow. The other option, of course, is to make sure that our snap zone is only enabled when we pick up the bow. I actually like that idea. I actually like that idea. So let's make sure that we can only load an arrow. So that means that our snap zone should be off by default. And when we drop our bow, we are no longer able to hold the arrow. All right. So this drop object should hopefully still call our dropped, which would actually end up firing. So if we drop our arrow, our bow will automatically fire the arrow. That's actually kind of cool. I'm going to leave that in. All right, so let's go and get some logic for firing the arrow. So the first thing that we need to know is, we haven't reset our pivot. So we can actually probably just copy that from here. Go back. And with that, we know the strength. Now the other thing is that, yeah, work. So that's going to be a value between 0.1 and 0.4 because that's how far back we pull it. All right. So now we need our arrow. So how do we get what it has picked up? Can pick up. Is picked up. No, drop objects. There you go. I might just go and just the other thing, of course, we can fire without an arrow loaded, so only go to fire our arrow if we actually have an arrow. Okay. So if we have an arrow in a bow, we're going to figure out, okay, how far is that? Move back. All right. All right, so the first thing is that we want to drop our arrow. Now at this point in time, because in our snap zone logic, we are not giving it any velocity, this is gonna hang in the air. So we can give it a velocity based on this. However, that we need to have in global space, which is why we needed our pullback for. But here we can say arrow, and that needs to actually be a rigid body. We don't really care that it's an arrow type. Linear velocity is going to be so. That was an X, so we're going to do pulled back. However, that is in local space. We need to transform that into a global direction. So we can just use our normal. I think. Now, it's very possible that our arrow is going to shoot the wrong way. Seeing we are giving now a speed in meters per second. This is going to be very slow. We're going to find out that when we pull back our arrow to the maximum amount and we're going to let it go, our arrow is going to go bloop. But that is fine for now, for our trial. I'm going to add a factor to this that will make it go faster. But we still want it proportional to how far we are pulling it back. Shooting multiple arrows at the same time, Robin Hood style. Yeah, we need some homing arrows then as well, I think. Okay, so adding VR support to a finished indie game. That depends on the game. However, if you join our wonderful Discord server, our Godot Discord server, not my personal Discord, but the normal Godot one, and you go to the XR channel, you'll find a guy called Teddy Bear. And he's doing exactly that. He is picking up a whole bunch of little indie projects made in Godot, and he's adding VR support to that, and he's having a ball with it. So he's first of all the best person to ask because he's got experience with it, but also looking at what he does and how he does it, I would say it's relatively easy to add VR support. Whether it makes the game immediately playable, that really depends on how well the game lends itself to VR. But yeah, he has some really good experience with that. And he's converted a whole bunch of existing Godot 3D games to VR, which is quite neat, actually. Very impressive. All right, so the last thing that we want to do here, and we're just going to add it up here. No. Oh, there. So I think 0.1 wait time is more than enough for this guy. We're going to call that arrow snap zone timer, timeout. So here we're going to go and enable our snap zone again. However, we're only going to make that true if we're still holding the bow. If you drop the bow at this point in time, or if we shoot the arrow because we dropped the bow, we don't want to enable our snap zone. We want the snap zone only enabled when we're actually holding up. Let's see how well that works. And one of my controllers shut down again. Okay. Yeah, I definitely feel that it's something with the physics engine. Whenever I bring certain collision shapes close to each other, the physics engine starts to go. Oh, our arrows are rolling around. Okay, so we do need to get some grab points for the arrows here. My frame rate is. Oh, see, this is what I mean. It just automatically loads the bloody arrow. Anyway, as far as we pull it, and like I said, it's going to hardly do anything with it. But oh, come on. It's too small. Can't pick it up. All right, something was pushed. All right, that's a funny bug. Okay, who is pushing me? All right. Okay. Something is got the wrong type. Put that on the graph now. And I think that is also why we're getting our physics engine going haywire. Okay. So, is that my pull pickup? I think it is. Because that's a static rigid body. Which means that if it's not being picked up, it's actually processing. And it's in every layer. And The thing is with our pull pickup, we're really only interested in being able to grab it and picking it up. But now, because we're moving our bow close to our body, that is actually pushing onto our body because it is in the incorrect layers. All right. That sucks. All right. Let me think. How are we going to do this? Because really what we want is this just to be an area. But do we have an area type? Malcolm, are you still around? Do we have an area type that we can pick up? We have an interactable area, but that's not really what I want. Let me think. All right. Well, the easiest thing to do, first of all, oh, there's no layers. Oh yeah, because we're disabling the layer. Oh. So when we look at our player body, our player body is checking collisions in the first 10 layers. So any object that's in those first 10 layers is going to collide with our body. So the easy thing to do is to put our pull pickup in layer 11. Is 11 smart, or was I using 11 for something else already? No, I'm not. So I kind of like to name my layers to know why I'm using that. So in layer, I'm going to we're going to put in there. But that also means that for our function pickups, we actually see we can actually only grab things in layer 1 by default. So we're going to add layer 11 to that as well. And that means that in our bow script, we are going to go and put this guy in that collision layer. Now I'm going to make a const for that. Pull pick layer is 11. Oh, 1 shifted by 11. I think that should work. Do there. And we do that there. So that should move our little pull pickup thing into a separate layer. Now our bow, I want to have a look at that, is just in layer 1 with mask on, so our bow is not going to interact with our pull pickup. And our snap area is obviously, well, that's another thing that's going to be interesting and something worth thinking about. Because again, our physics engine is going to be checking a lot of these. And in this case, for instance, our area snap zone is continuously colliding with our bow. Even though our bow at this point in time is turned off. But I'm actually thinking that our arrow should actually be in layer 2. And then in the arrow here as well, we're going to move you into layer 2. Arrows. Or actually, I'm going to call that projectiles. All right. So that's going to be in layer 2. So a projectile can interact with a player's body. I could, in theory, shoot myself. Hit myself. But it's not going to interact with a whole bunch of other things. And that definitely is going to be important when we shoot her. Now, the problem that I do have right now is that in this current setup, my arrow could theoretically go through could go through a table and things like that. So there's more to it. I am going to need to do more. But for our experiment right now, I want to do that because I want to prevent the bow and arrows from colliding to each other. Now, person, it was actually the snap zone that was pushing against it, because once you pick up the bow no longer has its collisions enabled, which is kind of nice. Actually, seeing that, I think, no, putting the arrow in a different layer is overkill in this case. So let's undo that. Because, yeah, the bow is actually taken out of the collisions the moment it's picked up. It was the pull pick that was colliding with the user body. And that is also something that, because whenever you got these sort of crazy collisions, the physics engine really starts doing overtime. So I think that is why I was getting all my frame drops, is because the collision system was really not handling that very well. Oh, why do I hear my... Oh, that's why am I putting my headset on? I need this guy. Yeah. Getting tired, I think. There we go. All right, 1, 2. See if that's working properly now. All right. Well, we still have our arrows that are just deciding to roll around like crazy, which is really interesting. Okay, this is just really annoying because these guys are too close to each other, and again, my frame rate is completely shot as a result. So yeah, for it to figure out what is closest, and yeah, we immediately get that snap again because our bow is now enabling that. Okay, but we're not going to the right one there, so we're missing something there. And all our arrows are now falling around. That's really annoying. Okay. Yeah, I'm really wondering what the... Yeah, it's definitely not happy about this. Okay. I'm guessing everything's holding on to each other. It also doesn't help that I'm sitting down. I really need to stand up for this. I need to find a better way to do my arrows. Oh, I forgot that's why it's not working. I have to, of course, go and arrow snap. No, not actually. Let's go and use the full thing there. Again, I need to put it on ready bar for that, but got to start my timer to reset that. Okay. So I think that the pickup layer is being calculated wrong. I'm shifting it by 1 too many. I need to do that by 10. It's interesting. Yeah, because it's of course layers. No, 0 is layer 1, basically. All right, let's see if I got that correct now. And I'm actually going to do a standing. So that's going to be, I'm going to be half of camera, I'm afraid. Yep. Oh, what did I just do? My whole screen went black all of a sudden. Yeah, I'm definitely having really weird frame rate issues. I would have got my debug shapes still on as well. But at least I should be able to. I'm still getting my Polaroid. Okay, so that's still the wrong layer. Why? What are you being difficult for? You know what? I'm going to make my life easy on one thing at least. I'm going to grab my arrows. Now, one other thing that I could do, and I'm very... Let's put my arrows over there. One thing I'm just going to do just to make my life easier. I know this is going to look weird. But we're actually going to do... Oops. Okay, I'm in the wrong... Nope. I'm going to make that a box. And the reason why I'm going to make the box is that they stop rolling around because it's annoying. Even though it's not accurate as a collision shape, at least that'll do. All right, so what am I forgetting here? I have not put my right hands to also use 11. Okay. All right. Let's see if that works now. All right, let's try sitting down one more time because I know we're really gonna stand up. Oh. 1, 2. Oh. That was very dizzy making. Put my arrows on over there. Very good. Grab the bow. Oops. Come on. Grab an arrow. Okay, so I still need to solve that. Snap the arrow to the bow. Grab the bow. Pull back. Okay. So it is, can't really see this, but it is falling and then it's snapping back. So our 0.1 timer is way too quick. First thing that I'm going to do, I know I'm going to need that. And the second thing that we're going to do is timer. Let's just make that a second. I'm not going to be reloading my my bow within a second anyway. The last thing that we want to do now is, there's a fire. Okay, we're actually going to make that a cons too. Fire. Let's make that something ridiculous at 50. That might be way too much. Let's do that. Okay. See if we can finally fire our arrows. All right. Yeah, and immediately once we do this, we can see that we're having. Well, that was shooting, but it also. No, I don't want you. Right. Oh, we need to put our highlight on our arrows as well. Okay. So we definitely get our arrow flying, but I don't know if we need to make it even stronger. We see that it falls down first. It falls to the ground. That could also be that we're actually. Let's try our last arrow. Come on. This frame rate thing is really annoying. We still don't know what's causing it because it's not the visuals, because these frame rate issues don't start until after I fire a couple of arrows. Okay, so why does it go down first? Okay, there is a, here we go. There is a ranged grab that you just saw me use. Um, Is that just gravity just dropping my arrows real quick? Or is my arrow not flying in the right direction? That's a big question. Yeah, I think it's gravity as well. And again, there's no lift on arrows, so it could just be that we are not shooting the arrows fast enough. All right, so what other? So let's first go to the arrows and let's go and add grab points for our left and right hand so that we can see how we're holding them. And just change the way that works. Okay. Oops. Go grab this thing. There we go. Kind of, you want to, yeah. Normally, you would grab it at the stem, and also, so. Again, we're doing this far from perfect. This is not how you load arrows. Well, you wouldn't even be holding it like that. But... yeah, well, close enough for our purposes of today. Too far in there. That's because. Oops. For purposes of today, that's good enough. Right, so now I also want to do the highlight thing. Copy, paste, so that it's in the same place. Oh, why does it have so many materials? That's interesting. Objects for highlights. Okay. So get some highlighting on the arrow so we can see which arrow we're trying to pick up. All right. Let us see, is this better? Yeah, that's what I was wondering about, Malcolm. I'm wondering if I'm doing the X form correct. There we go. Give an arrow. Oh, why did it not do that correctly? Yeah. It's made it much stronger now. Okay, if I go and do this. All right, that's definitely wrong. Okay. Whoops. Come on, arrow. There we go. Oh, I know why the arrow is wrong, because of the order. Actually, I want to do it really slowly now. Yeah, that goes straight down. Okay, so it's our direction logic that is wrong. And of course, once it hits the ground, it's going to slide down the ground. So one thing that I forgot about that's really important is you need to make sure that your hand snap points are always first, because it's going to grab the first snap point that applies, or the first grab point that applies. And the grab snap point works like a catch-all. So if you don't have any left or right hand grab points, it you'll still use a snap point. I am busy. I cannot answer right now. I will go back. Okie dokie. So I think keep giving noise if I don't do that. Okie do. Where are we? So it's a good question. Let me look at our arrow. Arrow is pointing in the direction of red. Look at a mass instance that is on the X. Oh, but also 90 degrees turned. Because we're in this. So you would expect actually that it would be the minus direction at that point. Look at the bow. The bow. X positive is that way. So indeed, if we look at a bow, that's 0.4. So the first thing is that should be negative. All right, so the things that I really enjoy doing for these sort of issues. You know you work, so I don't need you anymore. But I am going to go. Match instance, there we go. One, two. Okay. Let's move there. Never mind. I don't really know what I'm doing wrong. We want the global transform here because we want to project it in global space. So yeah. All right. Well, we can see that we're now grabbing the arrow where we wanted, but normally you would be loading the arrow like this. Maybe we'll actually go and place it. Okay, that is really cool. Come on, grab me an arrow, load an arrow. I'm gonna do this a little bit. Boink. All right, now the arrow does not behave like an arrow yet. But I don't know if anybody followed my tutorial on the dart game. We can have some fun with that. But yeah, there's a little trick that we can do in the arrow that once it's flying, that we're going to actually give it an impulse on the pins, depending on the difference between the direction of flight and the way the arrow points. Now, first of all, I think that this 100 was way too much. So I'm gonna bring it back to 25. Might be too little, but we were really shooting the arrow way further than what we want. We should. I also want to do a const for max pullback. And I'm actually going to make that a little bit more than we have right now. I'm going to put that in there just so that we have something to do with that. Okie doke. What a tokenizer error is all about. All right. Yeah, let's do that last thing today is make the arrow automatically adjust depending on our flight. Okay. So first of all, yeah, let's do our snap point slightly differently. So what I want to do instead, smooth it like this, like that. There we go. It's going to go like that. Let's see, what's this? Do it like that. Yeah, there we go. Doesn't have to be pretty. It has to be somewhat believable. Oh. What? Oh, wrong one. 19.0. There we go. There. Up a bit. Back a bit. There we go. That'll do for being able to put the arrow in place. All right. So we're going to inherit the scene or extend the scene as an arrow scene. Go. We're going to do a physics delta. There we go. All right. So our forward direction is Z. Yeah, we simply want to do a dot product between those two. Direction, forward. Motion is linear velocity. Okay, then our speed is forward motion dot length. There we go. This is always one of those difficult ones because this is in meters per second. I'm very good at thinking about meters per second. Let's just say 0.01. We don't want to do anything more if we're going too fast. Or no, we don't want to do this calculation if we're not moving. But we're going to base this on linear motion. Now, the other thing that I need to do, of course, is mode body dots widgets, because we're going to be static when the user is holding it. Okay. So the idea here is when you have an arrow, if it's moving in the direction, in a perfectly forward direction, the tail fins are going to just strain through the arrow. It's fine. But if you are moving at an angle of attack, so your arrow is facing up, your direction of movement is forward, then there will be a force exerted on the tail fins. So we can simply do a dot product between the forward direction and the forward motion to figure that out. So I'm going to call that dots. We're going to take forward motion. We want the normalized version of that. We want to do a forward direction on that. Okay. So now we know our angle of attack. Now the big question is, which direction do we exert the force? And that's always going to be interesting. So actually what I'm going to do here is, now that we already have the speed, is I'm actually going to say forward motion is forward motion of normalized, because I don't want to keep doing that. It's very wasteful to normalize things. So we're just going to do a dot between those two. Perfect. Now we know the angle of attack. All right. So we have those. Now this is the direction the arrow is facing. That is the direction we're moving in. We now want to have a vector in that direction to give our counter. All right. And for that, we're first going to do a cross product between the two. That gives us a pointing outwards. Forward motion cross forward direction. And then we're going to go and get a actually also want to normalize that. Always normalize these guys. And now we're going to cross again to get our up. So in this case, we want force vector is going to be our forward direction cross. Make it sideways. Okay, not normalized. Now, we might need to flip those two around, but I think that this is what we want, because we want to have the force going in the opposite direction. So, all right. Apply impulse, that was what I was all right. So this is also going to be fun because which ones are in local space and which ones are in global space? Apply impulse. I went onto the wrong, yeah. I didn't know there were more. Here we go, unrigid body. Apply impulse. Applies positional impulse on the body. An impulse is time dependent, which is great. Apply an impulse every frame will result in a frame dependent force while we're doing on the physics frame, so that's good. For this reason, it should only be used to simulate one-time impacts. Now we're going to be doing a continuous one. The position uses the rotation of the global coordinate system, but is centered at the object's origin. Okay, so we need to, yeah. And it doesn't tell us anything about the impulse. That's yeah, it doesn't tell us whether the impulse is in global space or in local space. Which is absolutely hilarious, in my opinion. I'm actually guessing that, yeah, it's equal to apply impulse, that, so I'm pretty sure that impulse is in global space. Nothing much else makes sense to me. Okay, arrow. So let's first find our position. And for that, we have our mesh instance. And the nice thing about actually is that because our mesh instance is positioned on the tip of our arrow, that is actually exactly where we want it to be. So actually, let's go in arrow mesh. So we're going to take our arrow mesh dot transform dot origin. That gives our local position, which we now have to make global, but only as far as rotation is concerned. Global transform, oops, dot bases, dot xform. And I think this is because they want, yeah, that actually makes sense because we're applying our impulse in global orientation, but local to the arrow. Really makes a lot of sense. That's going to be position. Then we're going to set our force vector times our dots. So that gives us, you know, the more angle of attack we have, the higher our correctional force should be. And then obviously we want to do that with a vector. So force vector. Let's keep that to 1. Let's just see how well it actually adjusts the. Okay, that needs to be R. All right. Well, that's why the speed is here, but I'm not sure what a good speed factor is for applying it. Although in the end, because I know that's the other one that I'm not doing in here. I'm actually not applying the speed into this. Because the faster we go, the bigger the correctional impulse should be. Yeah, so we might need to add the speed in here. And at that point in time, I think that this should be much lower. But it's gonna, yeah, it's gonna take a few tries to get that to a value that makes sense. All right. And of course, I roll my chair over this one. Alrighty. One hand, two hands. Got one of you guys. Put it in. And okay. My movement is too fast. Oh, where did I? Oh. Where's the third arrow? Oh, it's in the ground there. Okay. Okay, that was really interesting because first of all, it was rotating around the wrong axis. That's fine. I was kind of expecting that. But it was like it was doing it. Well, it could be because of that. Let's make sure that it does apply it right away. Oh, arrow, load. That looked really, really weird. It was doing something, but it wasn't doing what it is supposed to do. Okay, first of all, I don't think the forward direction is Z. Because we're actually doing it as X. And actually the forward direction is minus X. Okay, so that's our first problem. Because I'm used to it being Z because that's usually the camera is forward. Because of the orientation of the arrow, it's actually minus X. And that might actually also explain why it was going weird, because our vectors at that point, our dot at that point in time doesn't make any sense. Because we're going to have a really weird thing there. Okay, so for motion normalized, then we get our dots to get the angle between the two. So that's going to be 1 if we face the right direction, -1 if we are in the opposite direction. No, are we? Oh, that's indeed a good one. That's right. Forward, the dot is going to be 1 if we are already pointing. So this actually needs to be 1.0 minus absolute. No, I actually want to do that minus max. If we're facing the wrong way, if the arrow somehow ends up flying backwards, I no longer care what it's doing. Yeah. So now if it's if it's flying in the direction that I want, it's good. Dot's going to be 0. Should really give it a different. So if it's that, it's going to be 1. And that means that we're going to apply our maximum force. Then we do a cross product to get our perpendicular vector. Then we do another cross product to get our vector in the direction that we want to adjust. And then we take that vector times our dot times our force times our vector and times our speed. Okay, let's see what that does. When I did my Dart game, I actually ended up every frame I really don't like this stuttering thing. Whoa! Okay, so that's our cross being wrong. That was fun. Okay, I'm pretty sure that's because I need to do Actually, yeah, or direction. There we go. Okay. All right. We're doing what I did in my tests. Actually, it also reminds me that this one should really have continuous signal. Okay. Or yeah, that's all. All right, we're going to create a new mesh instance. I'm going to give it the same mesh. Yep. That's as top level is true. No. Set as top level. Thank you. It's true. That's going to make sure that it's going to ignore us as a parent. All right. So that's the first thing that we're going to do. So this is going to make every physics frame, it's going to make a copy of our arrow and show where it is. And we will actually be able to trace a path through the air as it moves. Also give us a little bit of an indication whether that is trustworthy. Now the other thing that I want to do here is for okay, that's going to become here. Mesh. Ready. Here. Oops. Create a new sphere mesh. Radius. One. Right. Two sphere mesh segments. Here. It's good enough to be small enough. Okay. Try that. Yeah. And now S-ray match dots global position, but we don't care about anything else. Oh, no, global transform. Origin is mesh instance global transform. Okay. Plus sideways times. Okay. So that way we can visualize what our vector is, whether our vector is pointing a sensible direction. All right. Let's see how crazy this is going to look. All right. Well, looking at the fact that we see lots of little thingies there are 0.1, definitely a bad. Sorry, I need to be back further. There we go. Oh, what? Well, there we can see that that's working. Yeah, this is going to be horrible right now because. All right, well, we're definitely seeing that our ball's in the wrong spot. They're pointing to the. No, that's sideways. Okay, I just used the wrong thing. But that's also pretty good indication that this is way too slow. All right, so let's do that. And I actually didn't want to decide, I wanted to visualize our force vector. Okay, sweet. Let's have a look if this is doing what I'm hoping it would do. Okay, here's my bow. Here's my arrow. All right. All right. The force vector does look like it's in the right spots. We can also see that our arrow actually adjusted itself pretty much like what I wanted it to do. Oh, wait, what? It's already loaded this automatically. That's really interesting. That's actually looking really, really good. That's actually behaving exactly the way that I was hoping it would. All right, we're gonna go and all right. Okay, I'm gonna do this differently. Plus. We're gonna 1 because the arrow is about 0.7, so there. No. Really? What do we have in here? Oh, of course. Actually, no. because if we're not moving anyway, there's no point in doing a check. Okay. What's wrong? Length this function. Very good, Baz. I think I'm getting tired, guys. Well, this is the last thing I'm going to do anyway. I just wanted to make sure that this adjusting of the flight direction is doing what it's supposed to be doing. Oh. See, when I just get the bow close enough to the arrow, it's going to load the arrow anyway, which is not what we want, but it's good enough for now. All right, so now we can much better see what's going on. We can see that our angle of attack is slowly being adjusted based on what we're flying. Now here we do see a problem that the moment we start going downwards, our vector suddenly goes the wrong way. So now we're suddenly, or is that because we have overcorrected? Yeah, because here we go back up. Okay, so we just, it's because we just overcorrected, that's why. Because now we can see that the little ball is below the arrow. So it's pushing the arrow to rotate back that way. No, sorry, the other way. It's going to go and push down on the arrow, and it's going to make the arrow move upwards again. So that's a potential thing where that's one way to load an arrow. Okay, let's go. Oh, what about we can actually push it way further than we should because the arrow is not long enough. All right. Yeah, I don't think I mind. Maybe we're overcorrecting on it now. Oh, the arrow. There we go. All right, let's see what happens if we just do it like this. All right. Well, one thing that I think is that we're not shooting the arrow fast enough, because if I need to pull it back that far and it only comes to here, that's not really a very strong arrow. So I think our force is definitely wrong. Right. So we're going to make a few adjustments. The first thing on bow is I'm actually going to be putting that back up to 100 because that was actually a pretty good one. But the other thing is I think that our force vector, I'm going to make that a lot smaller. Let's see how much it adjusts the arrow trajectory now. Oh, why did that shoot it already? That wasn't quite what I had in mind, but we can see that our adjustment is still there. Okay. Can we please do it properly now? Okay, that's a much nicer shot. Okay, I'll do one more like that, but not so high. Boom. Yeah, Malcolm, we need to make sure that we have some logic that we can only snap something if we just let it go from our hands. Okay. Okay. Yeah, we can see that here the ball is again underneath it, so the angle of attack is actually pointing slightly down. You can see that. Oops. You can see that when you look at it, you can see that if you draw a line from where it was to where the next one is, you can see that it's pointed slightly underneath. So the arrow has slightly overcorrected itself. And now our ball is pointing downwards because our fin is giving a upwards force at this point in time. And that would actually suggest to me that our force factor might actually be slightly too small. But other than that, this is actually pretty damn cool. Actually, I think that because this is a pretty long arrow, we also don't really need our continuous integration detection. Because we could see that when I was still putting an arrow every frame, it was actually not going too badly. Oof. Yeah, I'm very sorry, but that is pretty damn cool. Okay, frame rate's messing up again for some reason. And now it's fine again. Yeah, I think my adjustment force is too low now. That is cool. That is pretty damn cool. So I think that needs to go back to 0.1. I think our maximum pullback should go back to 0.5. And let's see how well we can shoot on our maximum pullback. Boom. Boom. Yeah, again, we still need to figure out why are we having these frame issues. Are we still... Okay, so that's as far as that we can go, which is actually pretty cool because it just gets our arrowhead nicely there. But are we now... Yeah, I still think that is a pretty solid shot. And if we do it like this... Yeah, that's not too bad. Now, one thing which I find hilarious is that once the arrow hits the ground, it actually skids along the ground. And to anybody who's ever done archery, that's... It should drag and it should slow down, so it's not applying any drag at this point in time. Yeah, what are you thinking? Is my frame rate correct when I drop the bow? Yeah, I think my frame rate is back to normal when I drop the bow. So there's still something wrong when I'm holding the bow, that something is colliding the wrong way. Anyway, all in all, that is a problem to solve, but not a really big one. Because one of the other things which is really important to realize, and that's something that I actually need to test, is this is a debug build that we're running on right now. And that means that none of the software optimizations is running. So it's very possible that if this is a physics issue, the physics engine is just going haywire, running this in a proper runtime, so properly exporting this, will actually make it work properly. That side, it is interesting because it seems that the physics engine is having a difficult time at things. All right, I am going to leave my little testing thing in there, but I am going to put a return in here to disable it because I might want to do more testing with that. But all in all, I think this works really nicely. It's nearly dinner time for me, so I'm going to call it a day there. I'm not checking this stuff into GitHub just yet because I first want to get the other two videos out. But obviously, I will be including this in the final version, probably as part of the fourth video. So video 2 came out yesterday, day before. Now I've done all the work already for video 2, or sorry, video 3. So I just need to do some recording and put everything together. So I might work on that next weekend. Not 100% sure. And then when I do the video on the pistol, I'll include the arrow logic as well, just to show it off. So yeah, pretty cool. See what's Malcolm all saying. Collision with a normal dot product against orientation greater than 0, and you may want to make the arrow static. Well, it's actually the next thing that we need to do, and I haven't spent time on yet, is obviously having a target that the. And again, yeah, you're right, because basically when it hits the ground. Well, I guess we just need to detect when it collides with something. That's really what it boils down to. And that when it collides with something, when it collides with the ground or it collides with the table, or anything that we want it to stick into, it should just at that point in time say, "Oh, I'm done. Gonna change myself to static mode, disable everything," and it's just stuck. So yeah. Actually, might be indeed quick to. So we want that to be off, but we want contact monitor to be on. We're gonna go and report one contact at a time. Let's actually just quickly do that, and then entered here. So yeah, let's only do it for the ground at the moment. Name 4. Mode is repeats. Let's set it. So. Original mask. Okay, so in this case, this is actually a good example of this functionality. Because now when it's in the ground, it's going to be static. But we still want to be able to pick it up. And then when we let it go again, it's going to be rigid again. So, okay. So that, because basically whenever we hit something at the right angle, we wanted to make it static that it puts in. But if, for instance, the arrow hits, well, I don't know. That's something to think about once we actually have targets to hit and stuff like that. But that's too much for today's stream. So let me just test if that works. The other thing is that there should be a small amount of bounciness in the. Okay, we're just going to make abuse of that. Fine, let's just do a bit slower. Ooh. All right, but should be able to grab it again, put it in my bow again, and now. Ooh. Okay, maybe our force is still a little bit too much. Pew! I love this. All right. Boink. sun location is actually wrong for some reason. That was something that I still need to fix as well, but I'll do that another day. Yeah, that's actually pretty cool. Poof. Boink. All right. Trying to put the bow down on my normal. Yeah. So obviously that's really simplistic, just to make it stick into the ground. But really should be checking against what things it hits, because obviously we want to make sure that it doesn't collide with the bow, so that we react to this at the wrong point in time. Or maybe even that should be it, that we simply ignore this with the bow. Although I guess also with these, so yeah, that's something that we need to experiment with to see, because you really want to have the arrow stick into anything it hits, except the bow. So yeah, but I've run out of time today, so that is for the next time to look into, or that might be something that I do part of the tutorial video. All in all, though, this is a pretty decent implementation of a bow mechanic in VR in Godot, and we did it in what? How long have we been streaming? Since 2, so we did it in just under 3 hours. Yeah, roughly 3 hours. That's not bad. So yeah, I put targets in the group, although again the problem there is that you would have to add everything that you could potentially hit with the arrows, and I think the opposite is probably better, is to say I'm going to ignore the bow and everything inside of the bow. So we might eventually put in maybe a group here, like an ignore group for the arrows, or one of the things that we could do is put the bow in its own what you call it? In its own physics group, something like that. Anyway, that's not something I'm gonna break my head over right now. That's something for a future video, future time, or something like that. Malcolm, one of the things that I'm thinking about, seeing that Teddy Bear was also talking about this. Once I polish this all up, I might just add this into a demo scene as well in our Xbox Tools demo. So we could have some fun with that as well. So yeah, the videos are all about how do you build it, but once it's built, people will just want to be able to use it. All right, guys, that was it for today. Thank you all for watching. I hope you enjoyed it, and yeah, see you guys next time.